Hi, welcome to statistics class. This is our lesson, hypothesis testing on one population. Okay, test of hypothesis on one population. So it involves formulating a hypothesis, sampling from a population, and checking whether the sample information substantiates the hypothesis of interest. For example, a test hypothesis about the mean, your variance, the proportion, or the sample size. So test of hypothesis on the population mean, mu, denoted by mu. This is our population mean. And then let hypothesize or mu naught or mu sub 0 be a hypothesized value of your population mean. So your hypothesis is mu or your population mean is equal to your hypothesized value mean versus your alternative hypothesis. So your population mean or mu is equal to mu sub 0 or your hypothesized value of your population, or mu greater than your hypothesized value of mu, or mu less than your hypothesized value. So remember this sign. This unequal signifies the two-tailed test, which also has a corresponding effect on your analysis, or it could be one-sided test. So greater than or less than. So what are the assumptions of the test on the population mean mu? So again, the sample is randomly taken from the population of interest. That is why you should learn or you should be familiarized with your sampling techniques. And the population is normally distributed. If normality of the distribution cannot be assumed, then the sample size must be large enough to invoke the central limit theorem. And usually, in statistical tests or analysis, they usually use an approximation of not less than 30 sample size. So approximate normal distribution, since usually or most of the statistical analysis can be approximated to normal distribution. So these are the assumptions of the test on the population which you should remember. So what are the possible decision rules? So we have our null hypothesis is always there is no significance. So your mu your is equal to your hypothesized mu, or your mean, or your variance it could be. So your test hypothesis. So your alternative hypothesis, as I've said, if you can see an equal sign, your population mu is equal to your hypothesized mu. It signifies that it is a two-tailed test in a distribution. And the decision rule, this is usually a default, or you should remember this: reject HO if Z computed or absolute value, since it is two-tailed, so it's greater than Z tabulated. So it could be your, depending on your level of significance. Then fail to reject HO otherwise. And then if you have your alternative hypothesis which states that mu is greater than mu sub 0, then it is a one-tailed test. So reject HO if your absolute value, computed value of Z is greater than your Z tabulated. Fail to reject HO otherwise, or if it is less than. And then if your test is your population mu, your mean, is less than your hypothesis value or one-tailed test, reject HO if absolute Z computed is less than Z tab. Fail to reject HO otherwise. So null hypothesis is usually there is no significant difference, relationship, or difference. So what is stated here is only your alternative hypothesis. So please take note of that. And then one of the common one population test of hypothesis on one population is Z-test. So it is used or this test is used whether the mean of a population is greater than or less than or not equal to a specific value. And so you want to test if a specific value and their hypothesis value are just the same or really different. So the z-test is a statistical test for the mean of a population. So it can be used when your sample size n is greater than or less than 30, or when the population is normally distributed. Actually, there is normality test that you should know before you use this one. And standard deviation is known. So the formula for the z-test is z computed, or this is your z value, x bar, that is minus mu over sigma over the square root of n. So where x bar is your sample mean, and mu is the hypothesized population mean, and sigma is the population standard deviation, and n is your sample size. So example, in the wind speed, it can be found in page 420 in our textbook. So a researcher claims that the average wind speed in a certain city is 8 miles per hour, and a sample of 32 days has an average wind speed of 8.2 miles per hour. So the standard deviation of the population is 0.6 mile per hour. So at level of significance alpha is equal to 0.05. So we will test if there is enough evidence to reject the claim. So we will use the p-value method. So using the hypothesis testing or steps to hypothesis testing that we have in our previous lesson, we will still use this one in our z-test. So step 1, state the hypothesis. You can state it this way. So your null hypothesis mu is equal to your to 8. That is the claim according to the problem. Or in textual form, there is no significant difference to the claim and to the sample mean. So your alternative hypothesis would be mu is not equal to 8. So we can see here in our hypothesis that it is a two-tailed test. So set the criteria for a decision. So based on the problem, our level of significance or our alpha is 0.05. And then our test statistics, our z computed is x bar minus mu over sigma over square root of n. So substituting the values, we will have the 8.2 minus 8 over 0.6 as our standard deviation over square root of n, or sample size. That n, using your basic techniques and computation, you will arrive in an answer of 1.89. Okay, so step 4, we should set our critical region and have a decision. So our step 4 is critical region. So remember, this is default. So reject HO if z absolute z computed value is greater than 0.05. Divide 2 since it is two-tailed, where z computed is equal to 1.89 based on our computation, and 0.05 divide 2 is equal to 1.96 based on our table in our z table. Since z computed is less than 0.025 tabulated z value, hence fail to reject HO. So note this, that alpha is equal to 0.05. So if it is two-tailed, then alpha is equal to 0.025 in the other tail. Now, our distribution is, the total probability is 1. So 1 minus 0.025 is equal to 0.975. Then this p-value, find the corresponding z-value in table E to find the z tabulated value. So example, here in our table E, so 0.975. So we have to find it. So this is the value, so 0.975. So the z value would be 1.9, and then this one 6. So our z tabulated is 0.96. So our decision is fail to reject HO. Hence, mu is equal to 8. In our conclusion, there is not enough evidence to reject the claim that the average wind speed in a certain city is 8 miles per hour. So you can also use p-value method by finding the area of the computed z is equal to 1.89c, our textbook in page 418 to 420 for more examples. So you have to remember this decision rule when using p-value. Okay, so if p-value is less than or equal to alpha or your level of significance, and our default one is 0.05 or 0.01, then your action would be reject the null hypothesis. So if your p-value is greater than alpha, or your level of significance, then fail to reject the null hypothesis. So you have to learn how to properly use or how to have a proper and correct null and alternative hypothesis. So this is a default rule in all hypothesis testing, especially in using software, statistical software. You don't need to look for the test statistics tabular value just like what we did in our Z table. You just have to look for the p-value and compare with your level of significance. Then you can have your decision and then your conclusion. So this is the guidelines for p-value. If p-value is less than or equal to 0.01, then your action is reject the null hypothesis. And the interpretation of that, the difference is highly significant. If you can observe in some researches, you can see they're significant and then highly significant because is it's the matter of it's the matter or difference between you're putting your level of significance. So it could be 0.05 or 0.01. And 0.01 is sensitive. That's why if there is significant difference, they call it highly significant. And then if your p-value is greater than 0.01, but your p-value is less than or equal to 0.05, then reject the null hypothesis. And your interpretation and conclusion with that, the difference is significant. And if p-value is greater than 0.05 but p-value is less than or equal to 0.10, consider the consequences of type 1 error before rejecting the null hypothesis. And then if your p-value is greater than 0.10, do not reject the null hypothesis. The difference is not significant. So for our reflection, when men close their eyes to that light that God sends them, they will reject the most evident truth and believe the most foolish error. So, in reality, rejecting the truth is just like committing a type 1 error in this life and in our spiritual aspect. So, may we be guided with our Holy Spirit in finding the truth and having a right conclusions in our decision makings. So for our next topic, see you in our t-test. God bless you and have a nice day.